equal osteogenesis inadequate and excessive osteoclastogenesis. For the osteoporosis treatment is usually with frequency the hormonal reposition. The collateral effects, however, like pain and edema for breast for women, led an increasing search for alternative therapies, such as calcitonin and SERMs. SERMs are used to treat various conditions, such as breast cancer, osteoporosis, and cardiovascular disease. The raloxifene is the unique SERM approved by FDA for the treatment and prevention of osteoporosis in the United States and many other countries due to its preventive effect and the incidence of vertebral fractures in women with postmenopausal osteoporosis. Another therapy is with bisphosphonates. For example, alendronate sodium is an inhibitor of bone resorption. Alendronate is a part of second generation of biphosphonates, which has less side effects than the first generation. The class of these drugs is analogous pyrosulfates and exerts its anti-resorption by binding to hydroxyapatite, inhibiting the development of osteoclasts and their migratory activity, and also promotes apoptosis of these. Due to the great affinity for bone matrix, approximately 50% of the absorbed dose remains fixed in the bone, and the rest is eliminated slowly with a half-life about 10 years with no signal of metabolism. After extraction, the phase of alveolar repair consists in cell proliferation, development of connective tissue, maturation, and mineralization. The purpose of bone repair is to fill the area forming bone. This remodeling is based in balance between osteoblasts and osteoclasts. RANKL expressed in osteoblasts connects to RANK, another protein expressed in osteoclasts, activating them. Osteoprotegerine connects in RANK, controlling this remodeling. And finally, for mineralization, another proteins, non-collagenous proteins like osteocalcin is in the process. Considering the increasing life expectancy, the number of elderly people with osteoporosis, and the demand for dental treatment for replacement or missing teeth, it's necessary to understand better the bone formation of osseous tissue in the alveolar repair process to achieve a higher quality of bone. So, our objective is evaluate the alendronate influence in the alveolar healing process of female rats with induced osteoporosis. For materials and methods, we use 48 adult rats, and they were submitted to a normal diet or calcium-poor diet. A method proposed by Teofilo et al. Consists in ovarectomy associated with a low calcium diet, decreased bone mass 2 times higher. The sample was divided into normal rats with diet balanced, whose name is control, ovarectomy rats with a low calcium diet and no treatment, and ovarectomy rats with a low calcium diet more the medicament, alendronate. For experimental design, day 0 corresponds to the day it was realized the ovarectomy or the fake surgery, and was initiated the normal or low calcium diet. After 8 days, who correspond to menstrual cycles, was initiated the alendronate treatment for on the corresponding group. At day 38, with osteoporosis induced, was made the dental extraction of the 3 groups. After 14 days, at day 52, was realized the euthanasia of the animals. And 42 days after extraction, at day 80, was realized the euthanasia of the half other part of the animals. All rats were submitted to dental extraction under anesthesia and aseptic precautions and were sutured with polyglactin wire. All rats were submitted to surgical stress of ovarectomy, but ovarectomy was performed in the treated and untreated groups, so control group made a fake surgery. For the preparation of histological slides, we used the paraffin technique and stained with hematoxylin and eosin. For the analysis of results, we used the histometric analysis and immunohistochemical analysis. For histometrical analysis, was overlaid 2 Mears grid on each cervical third of the alveolus to estimate the volume of clot, connective and bone tissue formed. Each grid contains 100 equidistant points, so the total 200 equidistant points. This analysis was conducted without knowledge of the examiner and made in 2 histological slices from each animal. The data for histometric evaluation of the results of the area of the clot, connective and bone tissue were statistically analyzed using non-parametric Kruskal-Wallis. Statistical difference were considered significance when p smaller than 0.05. For immunohistochemical analysis, we use antibodies against trap, osteoprotegerine, rankel, and osteocalcin, and they was classified by scores: light, moderate, and intense. Analyzing the results. For the clots to 14 and 42 days, the lowest mean value was found in control group and the largest for non-treatment group in both periods analyzed. Was observed statistically significant difference between group alendronate and no treatment. For the connective tissue to 14 days, the lowest value was found in the alendronate group and the largest for control group. Was observed statistically significant difference between control and alendronate group. To 42 days, the lowest value was found in control group and the largest in no treatment group, but there was no statistically significant difference. For the bone tissue to 14 days, the lowest value was found in non-treatment group and the largest for alendronate group. There was no statistical significance difference between them. To 42 days, the lowest is still non-treatment group, but the largest now is for control group. Here we can observe that all groups of 42 days have more new bone formation than 14 days, but with great difference between them, like non-treatment in comparison with other groups. In control group, we can see a lot of osteoprotegerine, which helps to regulate the activation of osteoblasts. In the no treatment group, we can see a lot of rank out and trap, indicating activated osteoclasts. We also observed little amount of osteoprotegerine and osteocalcin. In the alendronate group, we can see especially osteocalcin, but we can see a lot of rank out too. So, for scores obtained, the control group presents a lot of osteoprotegerine and light for activating osteoclasts. Non-treatment group expressed a lot of rank-out and trap like expected. For the alendronate group, is expressed a lot of osteocalcin. Expressed a lot of rank-out too, but the osteoclast is not activated like in the same intensity like the non-treatment group. So we can conclude the overreactin associated with a low calcium diet is really efficient for induction of osteoporosis. There is a loss in the dynamic response of alveolar repair process front of osteoporosis. And the alendronate improved the alveolar repair in osteoporotic rats, but not enough to achieve the histometrical values and protein expressions that were observed in the control group. And also integration in this case of osteoporosis is still controversial about oral alendronate, so future research will explain to us. That's my reference. Sorry for my nervousness. Thank you for your attention. Thank you, my friends from Brazil. And I'm open for questions.